That sound was recorded on the surface of another planet. Not reconstructed, a physical microphone sitting on a Soviet spacecraft the size and shape of a pressure cooker picked up actual wind on the surface of Venus and transmitted it back to Earth. Most people have never heard it, and that absence, the fact that 12 successful landings on another planet have been almost entirely scrubbed from public memory, is the first strange thing about this story. Before this video ends, you are going to watch a machine crash onto the surface of that planet and keep transmitting for 23 minutes. You are going to hear about engineers who built spacecraft capable of surviving pressures their own calculations said were impossible. And you are going to hear about one small mistake that made a ruin of every ruble spent putting it there. But none of that makes sense until you understand what Venus actually is. Because for a long time we didn't. We looked at the second planet from the Sun. Same size as Earth, same density, and we assumed it must be something like home. But we were wrong in various ways. In the early 1960s, Venus looked like a solvable problem. Astronomers knew the atmosphere was thick. They knew it was warm. Some papers suggested tropical conditions. One MIT study proposed Venus might be locked in a permanent ice age, its clouds reflecting so much sunlight that the surface stayed cold. Scientists argued about whether anything lived there. The Soviet Union began launching probes toward Venus in 1961. The first attempt failed to leave Earth orbit. So did several after it. The Soviets didn't announce those. In keeping with standard Cold War practice, failed missions were quietly renamed and buried in the records. Only the ones that worked got the Venera designation. By 1967, after years of failures, they had something they believed in. Venera 4 had been tested in centrifuges, running at 450 times the force of gravity. Its pressure vessel was rated to 25 atmospheres, roughly 25 times the pressure you feel standing at sea level. The engineers at the NPO Lavochkin Design Bureau outside Moscow considered that a generous margin. The worst estimates for Venus surface pressure at the time were around 10 atmospheres. They had built in a buffer more than double that. On October 18, 1967, Venera 4 entered the Venusian atmosphere. For 93 minutes, it fell through the clouds, transmitting the entire way. Temperature readings, pressure readings, atmospheric composition, 95% carbon dioxide, a number so far outside expectations that Carl Sagan publicly speculated the instruments had malfunctioned. Then the signal stopped. Moscow announced a landing. The probe's altimeter had sent a final reading of 26 kilometers, and mission controllers interpreted that as ground level. They held a press conference, but the American spacecraft Mariner 5 had passed Venus the day before, and what its radio occultation instruments measured told a completely different story. Surface pressure on Venus wasn't 10 atmospheres, it wasn't 25. It was somewhere between 75 and 100 atmospheres. Venera 4 had been crushed, not at the surface, but somewhere around 22 kilometers up, still falling, its hull failing as the pressure outside exceeded everything it was built to handle. The altimeter reading of 26 kilometers had been a measurement error, what engineers later called an integer ambiguity in the radar system, where the signal's return timing wrapped around and produced a false reading. American and Soviet scientists sat down together at the Kitt Peak National Observatory in Arizona, March 1968, one of the first joint planetary science conferences of the Cold War, and worked through the combined data from both missions. The conclusion was uncomfortable for everyone. Venus's surface pressure was close to 90 atmospheres. Its temperature was somewhere above 450 degrees Celsius. To put that in physical terms, 90 atmospheres is what you would feel standing at the bottom of a 900-meter column of water, which is deeper than the ocean floor at most points, compressing your lungs, stopping your blood from circulating, and then at a temperature hot enough to melt lead. That is what the surface of Venus is. And every probe sent there before Venera 7 had been designed for something much friendlier. If they were going to reach the surface of Venus, actually reach it, not just die in the upper atmosphere, they needed to build something that had never been built before. A machine designed not to explore a place, but to survive it long enough to say anything at all. If you want to see where this ends up, hit subscribe. These videos take a lot of time to research and make. What they built for Venera 7 was a titanium sphere with no seams, no welds, and no holes in the pressure vessel, because every seam is a potential failure point, and failure on Venus is instant and total. The shell was designed to withstand 180 atmospheres, twice what the model said they would actually encounter. To slow the descent enough to survive landing, they used a parachute, but they made it small deliberately, only 2.5 square meters, because the atmosphere of Venus is so dense near the surface that even a tiny chute provides significant drag. And a larger one would mean more time in the heat. Every extra minute inside that atmosphere was a minute closer to the electronics cooking from the outside in. The goal was to get down fast, hit hard, and still be transmitting. They chilled the probe to -8 degrees Celsius before atmospheric entry. A cold battery stored inside a hot environment. The cold would bleed away as the probe descended, buying time before the heat reached the instruments. Venera 7 launched from Baikonur Cosmodrome in Kazakhstan on August 17, 1970. Its twin, Cosmos 359, launched 5 days later and failed to leave Earth orbit. 4 months later, on December 15, 1970, the probe entered the Venusian atmosphere at 4:58 in the morning. The parachute deployed at 60 kilometers altitude. Atmospheric data started flowing back immediately. 97% carbon dioxide. Pressure climbing with every kilometer of descent. 6 minutes after the chute opened, it tore. Not a catastrophic failure. It didn't shred completely, but it collapsed enough that the probe began falling faster than planned. For 29 minutes, Venera 7 fell through hurricane-force winds in near freefall, tumbling, the weakened chute offering partial resistance, but not enough. At 5:37 in the morning, it hit the surface at roughly 60 kilometers per hour. The signal appeared to stop. Controllers watching the telemetry saw the transmission drop almost to nothing. The moment of impact. 1 second of strong signal. Then what looked like static. They assumed the probe had been destroyed, or had toppled and lost antenna alignment. The tapes kept recording anyway, because that was the protocol. A few weeks later, a radio astronomer named Oleg Rziga sat down to review those tapes. He was looking for anything salvageable in what everyone assumed was noise. And buried in the static was a signal, continuous, stable, transmitting temperature data without interruption for 23 minutes after the moment everyone thought Venera 7 had died. The probe had survived the impact. It had probably bounced, then come to rest on its side, its antenna pointed away from Earth. That misalignment was why the signal was nearly inaudible. But it was there. Venera 7 was sitting on the surface of Venus, transmitting, and nobody had realized it for weeks. What it said in those 23 minutes, surface temperature, 475 degrees Celsius. Pressure, approximately 90 atmospheres. The numbers matched the models built after the Venera 4 disaster. But now there was no ambiguity, no altimeter error, no disputed interpretation. A machine had touched the ground on another planet and sent back proof. It was the first time in human history that it happened. Venera 7 opened a door. What came through it over the next 15 years was stranger than anyone expected. Venera 9 arrived in October 1975 and sent back something nobody was prepared for: a photograph. The first photograph ever taken from the surface of another planet. Scientists at the Institute of Space Research in Moscow had expected darkness, or at best a dim orange murk. Instead, Venera 9's camera showed a surface lit well enough to read by. Light levels comparable to an overcast afternoon in Moscow. The image showed sharp-edged rocks, recently fractured and piled like rubble on a hillside, with nothing worn smooth and nothing eroded, a surface too young for wind and time to have touched it yet. Venera 13 in 1982 carried a microphone, the first ever deployed on another planet. What it captured was the wind you heard at the start of this video. A low, sustained tone, somewhere between a mechanical hum and something that has no good comparison in any sound you have heard on Earth. The engineers processed the recording and calculated the wind speed from it, between 0.3 and 0.5 meters per second, barely moving by any measure. But the atmosphere is 90 times denser than Earth's, so even that gentle drift carries force. Slow wind on Venus is not slow in any way that matters. Venera 13 survived on the surface for 127 minutes. Then came Venera 14. The mission launched 5 days after Venera 13, in November 1981. It was designed to drill into the Venusian surface and analyze the soil, the first direct geochemical sampling of another planet's ground. The camera lens caps were designed to pop off on landing, exposing the lenses. The drill arm was positioned to reach the ground at a specific point, directly in front of the probe. After landing on March 5, 1982, the lens cap ejected as designed. It landed on the exact spot where the drill was supposed to sample. For the next 57 minutes, the entire operational life of a machine that had traveled 261 million kilometers, Venera 14's drill pressed down on its own lens cap, measuring the compressibility of a piece of Soviet titanium instead of Venusian rock. The soil analysis that mission was built to perform was never performed. There is no clean way to react to that. It is too absurd for tragedy and too expensive for comedy. It is just Venus finding the one small thing that could go wrong and going wrong in exactly that way. The Venera program ended in 1984. 18 spacecraft sent, 10 successful landings. Survival times ranging from Venera 7's 23 minutes to Venera 13's 127. No probe has touched the surface of Venus since. The heat always wins eventually. But a small group of engineers at NASA has been working on something that might shift that. A cooling system that works by storing liquid ammonia inside the lander under pressure, then venting it slowly into the Venusian atmosphere. As the ammonia vents, it pulls heat away from the electronics, which helps to buy the valuable time the Venera probes never had. The math suggests a lander using this system could survive on the surface for up to 24 hours, not 23 minutes, not 2 hours. A full day on Venus. A mission called Venera D is currently in planning, intended to reach Venus sometime in the early 2030s. If it flies with that cooling technology, it will spend more time on the surface of Venus than the entire Venera program combined. There is something worth sitting with in the Venera story that doesn't get said clearly enough. Every probe sent to Venus was built to die there. The engineers knew before launch that whatever they put on that surface was not coming back. The mission was never survival. Survival was impossible. The mission was to transmit for as long as possible before the heat and pressure made transmission impossible. To send back as much truth as the machine could manage before Venus finished it. And they kept going, past Venera 4's false landing, past the crash, past the lens cap. 18 times they pointed a machine at that planet and said, "Go find out what you can before it kills you." The Venera 13 wind recording is 52 seconds long. In those 52 seconds, a titanium sphere sitting in 465-degree heat on the surface of the most hostile planet in the solar system sent us the sound of wind that no human being has ever felt and no human being may ever feel. We have the tape. Whether we keep going back, whether the next probe survives long enough to tell us something the last one couldn't, depends on decisions being made right now by people in rooms we'll never see, weighing costs we'll never fully understand, against questions that may not have answers. Venus has been there for 4.5 billion years. It is not waiting. It is not hostile. It is not anything so human as that. It is simply what it is, and we are still, after everything, trying to understand it.